நான் ரெக்கார்ட் பண்ணிட்டேன்.
ஓகே மேம். ஸோ அடுத்தது பாரு, நெக்ஸ்ட் டெரிவேஷன். டிரான்ஸ்லேஷனல் கைனெட்டிக் எனர்ஜி ஆஃப் கேஸ், இதுல இருந்து நம்ம என்னெல்லாம் வந்து we are going to derive it. ஓகேவா? we are going to derive it one or two factors. இந்த கைனெட்டிக் எனர்ஜி ஆஃப் கேஸ் வந்து how it is related to pressure, how it is related to Boltzmann constant or temperature, how it is related to volume. இது எல்லாத்தையுமே வந்து ஒரு சின்ன சின்ன டெரிவேஷன்ஸ்ல பார்க்க போறோம். இதுல எல்லாமே வந்து ஆல்ரெடி நம்ம பார்த்தது தான். இதுல பாரு, ஹெட்டிங் எழுதிக்கோ. From translational kinetic energy of gas, we know that kinetic energy is equal to half into mv square. Evening.
Yes, ma'am.
என்னாச்சு, ஊர்ல இருக்கீங்க அப்படிதானே?
My mom is a native, ma'am, so like she forgot her home. She couldn't send me the link.
Okay. Okay, ma'am. You can take this. So from the translational kinetic energy of gas, we know that kinetic energy is given by half mv square. So we can also write it down in the way the small m can be written as capital M. We know that m is equal to m small m into number of molecules n. Okay, and also we know that V RMS square divided by n is equal to VRMS square. Okay, so now we can write down the kinetic energy formula also as kinetic energy is equal to half into capital M into VRMS square. Okay, so now multiply and divide by 3 the equation, multiply and divide it by 3. So you will be getting 3 by 2 into 1 by 3 m VRMS square. Take down this equation. So already we have learned certain derivations. So adhilarindi we are bringing small outcomes. So kinetic energy, how it is related to pressure, volume and temperature. Okay, so multiply and divide by 3. So idukku appuram, so these things we know that in the portion வந்து நம்ம already தெரியும் நமக்கு. We know that pressure is related pressure is equal to 1 by 3 m by v VRMS square. நம்ம எப்படி படிச்சிருப்போம், பிரஷர் P is equal to 1 by 3 into rho into VRMS ஸ்கொயர்னு படிச்சிருப்போம். அந்த ரோ டென்சிட்டிக்கு பதிலா மாஸ் பை வால்யூம்னு தனியா எடுத்து எழுதியிருக்கேன். ஓகேவா? இந்த ஃபேக்டர்ல நமக்கு என்ன இருந்தது, ரோ வச்சு நம்ம டிரைவ் பண்ணோம் லாஸ்ட் கிளாஸ்ல. pressure P is equal to 1 by 3 into m by v VRMS square. So from that I am bringing this V volume to the left hand side. அப்போ அந்த ஈக்குவேஷன் எப்படி ஆகும், PV is equal to 1 by 3 m VRMS square. So here you can see in the second equation there is a factor 3 by 2 into 1 by 3 m VRMS square. So இப்போ இதுக்கு பதிலா நம்ம என்ன எழுதலாம், இந்த 1 by 3 m VRMS square க்கு பதிலா we can write down PV, pressure into volume. The product of pressure into volume can be replaced in the equation number 2. So I can write down that kinetic energy is equal to 3 by 2 into PV. 3 by 2 into PV. This is one outcome. Kinetic energy is equal to 3 by 2 into PV. Before this, we saw only one short derivation, Vivian. Maybe at the end of the class, I will tell you.
Okay, ma'am.
Kinetic energy is equal to 3 by 2 P into V. Now take this equation as the base equation, and we know that for ideal gas PV is equal to nRT, and for 1 mole of gas N will be equal to 1. For a 1 mole of gas N will be equal to 1. Therefore, this equation will become PV is equal to RT. Okay, so for 1 molecule of gas PV is equal to, for 1 molecule of gas it will be R divided by Avogadro number. So Avogadro number na enna paathom, it tells how many molecules are present in average in 1 mole of gas. Okay, adudana Avogadro number நம்ம பார்த்தோம் இல்லையா last classல. Number of molecules present in 1 gram mole of a gas தான் it's defined as the Avogadro number. Avogadro number எவ்வளவுன்னு பார்த்தோம், Na is equal to 6.023 into 10 power 23 per gram mole. ஓகேவா? இப்போ for 1 molecule of gas நம்ம என்ன எழுதுறோம், we are dividing this rங்கிறது universal gas constant divided by Na. R divided by Na is nothing but water. The universal gas constant divided by the Avogadro number Na will be equal to the Boltzmann constant. It will be equal to the Boltzmann constant Kb. Okay, so from the derivation, whatever we had, kinetic energy is equal to 3 by 2 PV. This is the derivation outcome. From that, we have also written that as PV is equal to Kb into T, Boltzmann constant Kb into T, we can write down the same equation as 3 by 2. Instead of PV, what I have written? I have written Kb into T. Boltzmann constant Kb into T. So these are two outcomes. You can use this in your numericals. Kinetic energy is equal to 3 by 2 P into V. Similarly, kinetic energy is equal to 3 by 2 Kb into T. In problem, if they are giving you Boltzmann constant K, use that and solve this kinetic energy formula. Otherwise, if they are giving pressure and volume, and you can use that other formula. So now you've got this VRMS equation can be written as VRMS is equal to, take down, these will be useful for your problems. So we can use it in this way. VRMS is equal to root of 3 Kb T by M, or we can write down root of 3 RT by M. The M, capital M is equal to mass into total N number of molecules. And as we know that PV is equal to RT, this can be replaced, this factor RT can be replaced with PV. And from the same equation, if I bring this V volume to the denominator, I can write down which is equal to root of 3P divided by M by V. So M by V is what? Mass per unit volume is density rho. So the same equation can also be written as Vrms is equal to root of 3P by rho. So this is one way you can write down. This is the second way. Otherwise, in terms of pressure and volume, you can represent Vrms. By using density and pressure, you can represent in the fourth. Okay. Now take down this problem. Calculate the RMS speed of nitrogen at STP. STP standard temperature pressure. So அதில் வந்து உங்களுக்கு temperature வந்து it will be at a standard temperature and pressure will be at 1 atmospheric pressure. Density of nitrogen in these conditions, they have given the density as 1.25 kilogram per meter cube. So last பார்த்த equation தான். So VRMS வந்து we can write it down as can be written as root of 3 PV by M, which can be written as 3 P by rho. So we have got density here, therefore I have taken this equation. Pressure is a standard atmospheric pressure. So at STP, pressure is given as, you can take 1.0 to 10 power 5 Newton per meter square. Okay, so pressure is available, density is available. Substitute in this formula and get the answer. I'll give you 2 minutes to solve it. When you substitute in the equation, VRMS is equal to root of 3 into 10 power 5 divided by 1.25. When you take the root, you will get the answer for around 490. 490. I got around 489 or something. 490 is the correct answer. Okay. Now take down this question. What will be the change in root mean square speed of gas on increasing pressure? Four options are given there.
Increases now.
Yeah, we'll you can see it. See, how do you say that?
The formula
Mm,
VRMS is equals to root of
mm,
3
mm.
P into V by M.
Yes, yes, yes. We usually think like that, na, because the formula is the VRMS is proportional, so it will increase. Like that only you think, no. Actually, a root mean square value will never change. Okay, a root mean square value is a mean value. It will not get affected. I'll tell you why. See, when the pressure increases, this does not change any RMS value. Okay, the increase in pressure, you can take down the solution. Pressure of the gas does not change. Why I'll tell you, does not change. The root mean square value from this equation, you know, the root of 3 pressure divided by rho. Yeah. So from this you can see we can know that this will be like VRMS square is equal to 3P by rho, or we can write down VRMS square into rho will be equal to 3P. Okay, you can see here how pressure and this VRMS are related. Okay, this VRMS, it will depend upon the temperature or the factor R, that is the universal gas constant. Okay, it is not depending upon the pressure is not depending upon the root mean square value. This will not change at any cost because it is a mean value. Okay, it's a mean square value. It will not get changed. It is directly depending upon this density rho. Okay, so VRMS depends on from this equation, it depends on 3RT by M. Yeah. So it depends upon the factors. It depends upon the factors R and then the temperature T. So here with the question, the answer will, it remains a constant. A root mean square value will never get changed. VRMS depends on universal gas constant and the temperature T. Next, take down. Which of the following parameters is the same for molecules of all gases at a given temperature? What is the solution here? So kinetic energy is equal to 3 by 2 kb into t we saw. இல்லையா kinetic energy நம்ம equation எப்படி பார்த்தோம்? Kinetic energy is equal to, we derived for it as 3 by 2 Boltzmann constant kb into temperature T. Okay, ba? So which of the following parameters is the same for molecules of all the gases? Molecules of all the gases at a given temperature. So speed is going to vary. Momentum is also dependent upon the speed v. Mass is also going to vary, which will not change. It will kinetic energy is going to be the same. Okay, so you can take down at specific temperature. At specific temperature, all all ideal gas molecules, they have same average kinetic energy. Take down. Next question. The RMS speed of oxygen at room temperature is about 500 meter per second. What will be the RMS speed of hydrogen at the same temperature? Okay, one clue I'll give you. Normal solution, the VRMS can be written as root of 3RT divided by the molar mass, M naught. So here R and T are constant. Universal gas constant R and T are constant. Therefore, we can write down that the RMS velocity is proportional or inversely proportional to the mass, molecular mass. Root of. So they have given RMS speed of RMS velocity of oxygen at room temperature is about 500 meter per second. Okay va? So RMS speed of oxygen கொடுத்துட்டாங்க. அவங்க என்ன கேட்டிருக்காங்க? What is the RMS speed of hydrogen at the same temperature? That is the question. So we will frame that question. VRMS for oxygen divided by VRMS for hydrogen will be equal to, it is inversely proportional. So I am writing down M for H2 and M for O2, the whole root. This will be the relationship here. What is given in the problem is for oxygen, they have given the value. The molecular mass of hydrogen and oxygen can be written as root of, actually for hydrogen it is 1, so multiply it by 2. So it will be 2 here, divided by, for oxygen it is 16. So 16 into 2 will be 32. Okay, and for VRMS you can substitute the value 500 for oxygen. So find out only this hydrogen. You have to find out only H2. Other all things are available. Tell me the answer, ma'am. You got this answer? Root of 2 divided by 32 will be equal to 1 by 4. And you got this answer. VRMS for H2 will be equal to 4 multiplied by 500. This is equal to 2000 meter per second.
Yes, ma'am.
Very good. Very good. Very good. Take down this problem. Calculate. Root mean square speed. அப்போ root mean square velocity ஒன்று கேட்டிருக்காங்க. ரெண்டாவது mean energy of 1 mole of hydrogen at STP. mean energy of 1 mole of hydrogen at STP. Kinetic energy கேட்டிருக்காங்க. ஸோ எப்படி கண்டுபிடிக்கலாம் ஃபர்ஸ்ட்? So first you can take down the VRMS formula. Here what is given? Density they have given. They have given rho. So directly I am taking this equation, pressure divided by density. VRMS, how it is related to density? I am taking that equation so that I can solve it easily. So now we know the pressure at atmospheric pressure will be 1 into 10 power 5 divided by what is the density they have given? 0.09. Okay. Now you find out the value of VRMS for hydrogen. Root means square speed of hydrogen. 3 into 10 power 5 divided by 0.09. You get the value of 1825 meter per second. Otherwise, you can write down 1.825 kilometer per second. Now you have got the VRMS value. What is the second question they have asked? They have asked to solve the energy, mean energy, that is the kinetic energy of 1 mole of hydrogen at STP. Okay, but 1 mole of hydrogen they have given, so I have to substitute the formula M, capital M into VRMS square, where capital M is the molar mass. So you can substitute directly what is the molar mass of hydrogen. It is 2 into 10 power minus 3 multiplied by the VRMS value. We have got the VRMS value here, meter per second. So I will substitute 1825 square because we found out only VRMS. Here it is VRMS square. So I am putting the whole square. This will give you the kinetic energy value.
The answer is
எவ்வளவுமா?
330.
Yes, very good. Okay. See, in the last class, you remember that I have said you in the introduction at standard temperature and pressure, that is at STP, the temperature 0 degree Celsius will be equal to 273.15 Kelvin and pressure will be equal to 1 atmospheric pressure. இல்லையா? அதே மாதிரி இன்னொரு பாயிண்ட் என்ன சொன்னா 1 mole of any ideal gas occupies a volume of 22.4 liters அப்படிங்கறதையும் மென்ஷன் பண்ணேன். What did I tell you? I said you 1 mole of 1 mole of any ideal gas occupies a volume of 22.4 liters. ஓகேவா? இந்த பாயிண்ட் வந்து லாஸ்ட் கிளாஸ்ல தியரி டிஸ்கஷன் அப்போ சொல்லியிருக்கிறேன். இப்போ என்ன கொஸ்டின் கேட்டிருக்காங்க பாரு. Molar mass is a volume occupied by 1 mole of any ideal gas at standard temperature and pressure at STP, atmospheric pressure 0 degrees Celsius. So show that it is 22.4 liters. They have asked to prove this. Prove this value. 1 mole of any ideal gas occupies a volume of 22.4 liters. They have asked to prove this value. Take down the question. So it is ideal gas. We know PV is equal to N into R into T. So 1 atmospheric pressure, that standard atmospheric pressure, pressure can be written as directly 1 into 10 power 5, or if you want to write down accurately, it is 1.013 into 10 power 5 pascals. And what is the universal gas constant R? It is equal to 8.31 joule per mole Kelvin. So what is the question they have asked? Volume. We have to show how the volume is going to be 22.4 liters. So take down what is V. V is going to be equal to N into RT divided by P. It is for 1 mole. So 1 into what is R? R is 8.31 multiplied by what is the temperature at absolute temperature? It is 273 we can keep divided by P, pressure. Okay, I am substituting directly 10 power 5. So calculate for this. I'm getting the value 0.0224 meter cube. So now we have to express this in liters. So 1 meter cube is equal to 1000 liters. So we can write down the volume V is equal to 0.0224 meter cube or 22.4 liters. We'll move to the next question. It's from the book back, take down. Calculate the fraction of molecular volume to the actual volume occupied by oxygen gas at STP. Consider taking the diameter of an oxygen molecule to be 3 angstrom. So they have asked to find out the calculate the fraction of molecular volume to the actual volume. This is the question. Okay, now what do they have given? Measurement diameter of an oxygen molecule to be 3 angstrom. Okay, they have a it is a very small value in centimeter. இல்லையா நம்ம எப்படி எழுதுவோம் நம்ம the diameter of an oxygen molecule. Diameter of oxygen molecule. They have given us D is equal to 3 angstrom. And when you want to find out the radius, you will find D by 2. D by 2 is going to be 1.5 Armstrongs, or we can write down 1.5 Armstrong can be written as 10 power minus 8 centimeter. 10 power minus 8 centimeter. We want to find out the molecular volume. V can be written as 4 by 3 pi r cube multiplied by the Avogadro number, which will be equal to 4 by 3 into 3.14 into 1.5 into 10 power minus 8 the whole power 3 multiplied by the Avogadro number 6.023 into 10 power 23. And tell me the answer. You get the answer as 8.51 centimeter cube. See what is the actual volume of any gas, because we need to find the ratio. So first actual volume of any gas is given by 22.4 liters. We have to mention it in centimeter cube. So we can write it down as 22,400 centimeter cube. So now find out what is the molecular volume divided by the actual volume. Molecular volume, we found out the answer as 8.51. We have kept the answer in centimeter cube only. So here in the actual will be 22,400. So find the answer. This will be the fraction of molecular volume to the actual volume occupied by the oxygen gas. Are you getting this answer? 3.8 into 10 power minus 4.
Yes, ma'am.
Okay, da, fine. Stop. Q க்கு அடுத்த key.